Okay, so we're going to start Chapter 2, Matter, Properties, and Changes. The first thing you should have done was answer the focus question. Why does the volcano spew blue lava? And so if you guys gave me your best guess answers, then now I'm going to give you a little bit of an explanation. So each element burns a different color, and we use this to tell those apart. And so in this case, the sulfur, which is coming out of the volcano, burns blue. So we're going to look at the different states of matter and then the properties of matter in this little snippet, and then you're going to have a little worksheet to work on. So for solids, you should be pretty familiar with these. They have a definite volume. They always have the same shape that they started with, so you can't change their shape without breaking the solid. And they're incompressible, meaning you can't squish them. Okay, so like if you tried to put a solid in a vise, you'd either just be able to press it up to a certain point, and then that's like the limit of the solid's volume, or you would break the solid into pieces, right? Liquids have definite volume and they take the shape of their container, so they don't have definite shape, but they are also incompressible, just like a solid. Okay, so you can't put a liquid in something and squish it and expect it to shrink down. Okay, this is how hydraulics work. So like your brake lines and stuff, when you put pressure on your pedal, there's a liquid in the brake line, it's brake fluid. It's incompressible, so it transfers that force directly to those brake pads, and that's just one way to transfer that pressure. And it's really efficient in cars. You don't have to worry about like lines breaking or anything, like if you had like a wire system. All right, so gases are unique in that they have no definite volume and no definite shape, meaning that they take the shape of their container, they expand to fill their container, and if you put them into like a syringe or something and you cap off the end, you can squish them. Okay, so you can make it smaller than the volume it originally was. Now there's a limit to that. At some point the gases get compressed to the point where they'll become something else, and then it'll go back to being, resisting that compression. And then the last thing that you may not be familiar with is a plasma. You've probably seen it, you probably just didn't know it had its own name. Plasmas are electrically charged gases. They're usually very high temperature, very high pressure. So things like your plasma balls, okay? You should see these in some novelty stores, things like Spencer's, Hot Topic, that sort of thing. And those are plasma. So usually those have argon gas in there. And then you plug them in, and when you touch it on the outside, right, you can focus all the beams in one spot. And all it's doing is it's releasing that static charge from the outside to the inside, and it's charging that gas to make that pattern. Okay. All right, and so we're going to go ahead and do the properties. So physical properties come in two categories. You have your intensive properties, which do not depend on the amount of substance present. Think intensive as being like intrinsic, or it's kept internally. These are things like density, color, and magnetism. So like copper is going to have the same density whether you have 10 kilos of it or 1. It's always going to have the same copper color, right? And it's always going to be pretty non-magnetic. Extensive properties depend on the amount of substance present. So these are things like the mass of something, the length of something, the volume of something. Okay, so these really rely on an amount. So that's the extensive property of mass changes based on the amount of copper you have. So 10 kilograms, right, is a different mass than 100 kilograms. Whereas if you had a 5 centimeter rod of copper, right, it's going to have a different length than a 10 centimeter rod of copper, right? There's a different amount of substance there. Okay. Chemical properties are totally different. Chemical properties describe the way a substance reacts with other substances. So these are things like rusting, verdigris, if we're going back to our copper, right? This is the oxidation of copper. So the Statue of Liberty looks like the way it does. and things like burning, vaporizing, dissolving. So if you put anything in a solution, it's going to react with its solvent, right? So those are all chemical changes. Those are all chemical properties. All right. So go ahead and finish up your guided notes for this section, and go ahead and move on to the next activity.